The upper half of an inclined plane of inclination theta is perfectly smooth while the lower half is rough. A block starting from the rest at the top of the plane will again come to rest at the bottom if the coefficient of the friction between the block and the lower half of the plane is given by. So first, let us try to visualize the given scenario here. So say this is the inclined plane, okay? This is the inclined plane. And the lower half is rough, right? The lower half is rough. Okay. So say this is the rough surface. And the upper half is smooth. So this much region is smooth. No friction here. Okay, so this is the primary thing given in the question. So there is coefficient of friction mu here. And here mu is 0. It is smooth. And what else do we have? A block is starting from rest, right? So say there was a block here, right? A block here like this. Now what is happening to this block? See, this block will slowly slide like this. It will go easily through the, I repeat, it will smoothly slide like this. It will smoothly slide like this, and from here it will experience friction. It will here experience friction, and then the speed will reduce, and eventually it will come down and be at rest. Okay, so this is the condition given to us. Let us try to visualize this once again. So let me call this point as A, this point as B, and the last one as C. So let us try to imagine the condition once again. Okay, so the object was kept at A, right? It is smooth, which means from A to B, the body will slide down smoothly. And then B to C, what happens is it will experience some friction and the movement will actually be retarded and eventually it will come to rest. Okay, so from A, smooth movement slide down, and from B, it will experience friction and it will slow down gradually and approach zero velocity. Okay, so this is given to us. So what we'll do is we'll try to figure out this question in a very detailed way, considering both travels from A to B and from B to C. But before we do that, something students often ask me as a doubt is the resolution of weight on an inclined surface. See, this is one such idea where if you don't give much emphasis on the logical reasoning behind this, what makes this, or rather, what is the primary reason which causes this inclination to resolve, if that idea is not there, you'll find it really difficult to do questions, especially at the JEE mains level. Well, not to underestimate NEET, and definitely this question is from 2013 NEET, the very first time NEET was launched. So these kind of concepts are really important. So we'll try to understand that concept first, resolution of weight in an inclined plane, and then come back to this question. Okay, so okay, let me take a different board now. Okay, so let us discuss about resolution of weight where on a inclined plane. See, I can assure you, if you pay much attention here, like you put your maximum focus here, this explanation will help you to understand any resolution when it comes to the inclined plane. Okay, I'll try to make it as simple as possible and as well. Of course, see, when I say simple, it may take some time. So the length of the explanation will definitely be more, but it will be as clear as possible from my end. Okay, let's see. So first, what we need to understand is, if there's a surface here, right? If there's a surface, and if there is a block placed on it, same mass m. If I were to draw a free body diagram, I repeat, if I were to draw a free body diagram of this block, what would I do? See, the first thing you need to understand is, what is free body diagram? It is a diagram which represents all the forces, all the forces acting on the object of interest, on the object of interest. So to get this idea clear, what we'll do is we'll consider two objects of interest here. Which all are they? One being the mass and the other being the surface. Once this idea is clear, you have the foundation to understand what happens in an inclined plane. Okay, so let us try to pay maximum attention here. See, what are the forces acting on? What are the forces acting on the weight m? We know that any object will experience a weight which is experienced towards the center of the earth, right? The earth will pull every object towards the center of it. We know that. Now, see, normal reaction is one such region where students often get confused by the statement. Normal reaction is an action reaction pair. Okay, it's an action reaction. So people ask me, which one do we take? Do we take the action or do we take the reaction? So that's where the doubt comes in. Let me clarify this. See, what we need to understand is when an object is kept on the surface, I repeat, when an object is kept on the surface, what happens is the object will exert a reaction, okay, which we call as the normal. Why do we call this normal? It assumes normal because it is perpendicular to the surface. So in geometry, anything which is perpendicular to surface, we call that as normal, right? So that's how the terminology comes in. Normal to the plane, normal. So there's a normal reaction which is acting on the surface. Okay. So this is acting on the surface and it is acting due to the mass m. Okay. So what is NSM? It is a normal reaction acting on the surface. Okay. Now, by Newton's third law of motion, we know that if there is an force acting, there would be equivalent opposite force acting. Now, this time this would be on the block and not on the surface. So the block will experience a reaction pair, say N, this time on M due to S. Okay. So I repeat that once again. So normal reaction acting on mass due to S, equivalent opposite normal reaction acting on the surface due to the mass. Okay. Now let us try to understand the free body diagram. See, when we say the free body diagram, if the object of interest is mass, how many forces are acting here? There are only two forces acting. One is the weight of the body acting downwards, and the other one is normal reaction on the mass due to the surface S. Right? We don't include the third force here. Why? Because the object of interest here is mass and not the surface. But if we were to ask to draw the free body diagram of the surface, how will it look like? It will look like this. And force acting on the surface. Which one is this? The normal reaction acting on the surface. Due to which the object present, due to the mass, to the block present here. Okay. So we won't see the other two pairs here, other two forces here. Okay. So those who are watching it offline, online, please make sure that you pause the video here. You go through this entire explanation one more time, and then move to the next one. Anyway, I'll repeat it one time. See, a block of mass m is kept. It is kept on a surface. It will be pulled down by the gravitation towards the center of the earth, resulting in the force mg. A normal reaction acting on the mass due to the surface. Equivalent opposite, Newton's third law, normal reaction acting on the surface due to the mass. Acting on surface, opposite and equal, acting on mass. Okay. Free body diagram, what is it? All the forces acting on the object of interest. If the object of interest is the mass, okay, I think it should be block, right? If the object of interest is the block, then what do we have here? There are two components. One is the weight, which is acting downwards, and the other is the normal reaction acting on the block due to the surface acting upwards. And when we consider the surface, how many forces are acting? There is only one force which is acting on the surface. Okay, so this is the concept behind the free body diagram and the forces acting on a block. Okay, now having said this, let us now try to understand what happens in a inclined plane. Okay, see, before we go to that point, let me add something more here. See, if you give more normal reaction here from the surface, what will happen? If this normal reaction is more than the weight, what will happen? The body will, say for example, the body is pushed upwards from the ground, right? If the normal reaction is less and if the weight is more, what will happen? The body will show the tendency to come down from the surface. If the normal reaction is equal to the weight, the body will stay there on the surface. Okay, so what I wanted to imagine is, imagine a piece of cake and there is a coin present on the top of it. So if the normal reaction is more than the weight, more than the weight, what will happen is the coin will get tossed upward, leaving the surface of the cake. Okay, if the weight is more, what will happen is the normal reaction is overcome with the weight and the coin would press towards the inner surface of the cake. And if both the forces are balanced, then the coin will stay. It will stay on the surface of the cake. Okay, that was a bad example, but I couldn't come up with another one so instantaneously. So that's try to visualize that concept. Okay, right. So okay, if you want to have further explanations, we can maybe discuss after the class. Those who are watching it online, if you want to have further discussion for the examples, please do write it in the comment box. I'll try to come up with a variation of forces there. Okay, now let's see what happens in the inclined plane. Okay, so okay, I mean you have to need a couple of diagrams to draw this. Okay, so let's say we have our inclined plane here. Okay, this is an inclined plane, and this angle is theta. This is 90 degree. So how much is this angle? This is 90 minus theta, right? Okay, let me name these points also. So we have A, B, and C. And this is the block of mass M. So if this is a block of mass M, let us try to find out the normal reaction. To try to find out the various forces acting on it. So we know that for any body kept on a surface, there will be two forces acting on it. Number one would be the weight, and number two would be the normal reaction, right? Normal reaction, which is acting perpendicular to the surface. Now, which surface? Perpendicular to the surface of contact, actually. Perpendicular to the surface of contact. So, which is the perpendicular surface of contact here? It is AC and not AB. It's very important. AC is the point where the object is in contact, right? So, normal force would be acting perpendicular to the, normal reaction would be acting perpendicular to the surface of contact, which is AC here. Okay. Now, let us try to understand the resolution part. So one more time, we have a inclined plane, right? The object is kept here. So say the weight originates from the center of the body and the weight is acting downwards like this. Okay. So what is this force? This force is mg. Now we'll have to resolve mg. Okay. Now how do we resolve mg? See, for that we need to first find out the angle which it is making with the, okay, let us keep an angle, let us discuss that in a separate video. So what we'll do is we'll try to resolve this force mg into two components. Okay, into two components, one which is parallel to the surface and the other which is perpendicular to the surface. Let me write it down first. So we will resolve mg into two components. Okay, one which is parallel to the inclined surface, one which is parallel to the inclined surface, and the other which is perpendicular to the inclined. See, we are taking longer than usual to complete a problem. See, those students who are here for the maybe the second or third revision, excuse me, this might be very elementary for you, but those who are here for the first time, and the students who are listening to the recorded sessions online, see, this is going to be a bit lengthy, but please try to focus your attention towards the explanation. Things will become very logical and things will become very clear to you, and I bet you'll be able to resolve any component here, and try to visualize what happens in the resolution. Okay, so parallel to the inclined surface, and one component will be perpendicular to the inclined surface, and this parallel to the inclined surface, we'll call that as the horizontal component. Horizontal component of weight. Horizontal component of weight, and the perpendicular to the inclined surface, we'll call that as the vertical component of weight. Okay, so say let this be W is equal to mg. Okay, so the horizontal component, for our ease of understanding, I'll write it as wx, and the vertical component, I'll write it as wy. Okay, so I'm going to solve it like this. One component perpendicular to the inclined surface. Okay, so we only have perpendicular to the inclined surface like this, right? And another component like this, which is parallel to the inclined surface. Okay, now I'll have to redraw this diagram, or maybe a couple of times at least. So I'm trying to take your attention towards this concept resolution again. Okay, so let's see. So this is the ground, the inclined surface. The inclined surface is AC. Now I'm going to draw only the forces. Okay, so the weight was acting downwards like this, right? This is mg, this is W is equal to mg. What do we need? One force which is acting perpendicular to the surface. So this is the inclined surface is AC, right? The inclined surface is AC. So the one which is inclined surface is AC. The one which is vertical component is WY, which means this vector here represents WY, right? What do we have next? Horizontal component. Horizontal to what? Horizontal means parallel to the inclined surface. What's the inclined surface? The inclined surface is AC. So we need one vector starting from this origin, which will be parallel to AC. Let us draw it here. So this is the next vector, and what do we call this as? We'll call it as Wx, right? The vertical component is Wy, and the horizontal component is Wx. Okay. Okay, so we have to solve this. Right, now see, being a vector, being all of these being vectors, what can we do is, we ideally can, okay, wait, what we can do is, let us see, considering this case here, okay, considering this case here, if I do understand this, suppose, say this is Wx, okay, this is Wx, and see, we know by the basics of vectors that this vector, if it is displaced from its initial position, it doesn't affect the, you can keep this vector anywhere in this plane and it doesn't affect the properties of the vector, which means if this vector is kept here, it acts as Wx, it doesn't matter where it is kept. So I'll take this Wx and keep it in such a way that it starts from the origin of this vector and it ends at the terminal end of the last vector. Okay, I repeat, this is Wx vector. It can be kept anywhere on the surface, but I'll keep it in such a way that it looks like this. Okay, like this. Now, okay, like this. Now let me. Okay, now we'll try to visualize this one more time. Okay, So we have the fixed surface. The fixed surface here. This is fixed. Then we have theta to be the angle of inclination. This was A, B, and C, right? And then we had one force acting perpendicular like this, right? Which is the main component mg. Then we have the inclined, the perpendicular force or the component, which what we call as wy, right? And then we have the wx component here, right? Now what we need here is to find out this angle theta, sorry, this angle, this component, this angle here. To find out that, what I'm going to do is I'm going to draw, okay, let me label these as well. So let us say this is D E F. Okay. Now see, to find out that angle, what I'm going to do is I'm going to draw only a couple of points here. So D E F, maybe this is E F, right? So this is G and H. Okay. So please try to pay attention here. I'm going to draw only certain lines here. So this is T, this is H. Okay. Goes like this, comes like this. So this is T, H. What do we have here? This is G, right? G and C. And this is B. See, one thing we know from basics of geometry is that DH is parallel to CB, right? Which means these two are alternate interior angles, right? So if this angle of inclination was theta, this is 90 degree by triangle sum property, this is 90 minus theta, and being opposite alternate interior angles, this angle will also be equal to 90 minus theta, right? Now this component, the wy component being the vertical component, this would be inclined at 90 degree to the surface, which means this angle here is 90 degree, right? So if this is 90, this is 90 minus theta, then the only possible value for this angle is theta. Okay. Please try to rewatch that. It's very basics of geometry. So we got these two components here, right? And now, if I had to draw the final diagram one more time, so we have the fixed surface here, fixed surface, right? A block W is kept, sorry, a block of mass M is kept. Weight is acting downwards. We have a vertical component and we have a horizontal component. The horizontal component is, vertical component is Wy and the horizontal component is Wx, and this angle is theta. Okay, so the triangle was triangle DHG with 90 degree here. So now again, a doubt which most of the students not from the mathematics background always ask me is how to understand this Wx and Wy. Let us take that point also here. So so it is DGH, right? Now guys, tell me if this is 90 degree, tell me what is okay, say if this angle is theta here, if this angle is theta here, tell me what is sine theta from here. Sine theta is opposite by hypotenuse, right? Opposite is HG, by the hypotenuse is DH. Similarly, tell me what would be cos theta, would be adjacent side being the closest one to this. So adjacent side is DG, the whole upon hypotenuse is TH, right? Now tell me what is HG from here. So HG is equal to DH into sine theta. And what is DG from here? DG is equal to DH into cos theta, right? So let me rewrite these two here. So HG is equal to DH sine theta and DG is equal to DH cos theta. Now let us try to bring these variables here. So what is HG? See from the figure, what is HG? HG is Wx, right? HG is Wx. So let us write it first. So Wx is equal to, what is DH? DH represents mg, right? So Wx is equal to mg into sine theta. That is our first important point. Wx is equal to mg into sine theta. And what is dg is equal to? Dg is equal to, let's look at it, dg is equal to wy, right? So dg is equal to wy, which is equal to, what is dh from the figure? Dh from the figure is mg. Dh from the figure is mg. So we'll write down here is equal to mg into cos theta, right? So two important derivations. One, that wy is equal to mg cos theta, and the horizontal component being wx is equal to mg sine theta. Okay, now if we come back to the question here, we were actually discussing about the horizontal component and the vertical component, right? So what is the horizontal component? Wx is equal to, if you write this, that becomes Wx is equal to W or mg sine theta, and the vertical component being mg cos theta. Okay. Now, see, this is taking really longer than usual, but as I always say, every problem is explained in such detail wherever it's required to address that student who is doing it for the first time. This goes for the online and the offline students as well, who's watching for the first time and who feels that his basics needs to be corrected from the very beginning. Is the reason why we are addressing every problem in this detail. Okay, sorry that I'm making the explanation really lengthy. Okay, so that was it. So we discussed about the resolution of the weight, right? So now let us come back to the figure one more time. So if this is the fixed surface, right? This is the fixed surface. If there is a block placed like this, the weight acting towards center of the earth, mg cos theta is the perpendicular component, and mg sine theta is the horizontal component, right? Now let me tell you the concept of why this is important. See, so this is the normal reaction, right? This is a normal reaction here. See, what I want you to do is, I want you to visualize that, say for example, this theta is equal to 60 degrees, okay? Let us reduce this theta, maybe to this. We still have the block here, right? We still have the block here. Now, the normal reaction would act like this, right? So the sine theta component here, weight is acting downwards. The cos theta component here, this is mg cos theta. This is mg sine theta, right? So maybe theta is 30 degrees. Let me try to even reduce theta. So maybe like this, small inclination. Now what do we see? The block is over here. Weight is almost perpendicular, right? This value is really small, mg sine theta. Mg cos theta is even smaller. Okay? And normal reaction acts like this. Would be definitely inclined at some point like this, right? And then if you were to make this theta almost equal to 0 degrees, there is no inclination, right? Two surfaces overlap, right? We know that force, the vector can still now be resolved. Now what are the components? It is mg sine theta, right? And mg cos theta. Now as theta is tends to 0, what is sine theta? Sine theta component is mg into 0. It is 0. So the horizontal component which was present earlier now disappears. Okay. So see, this was the horizontal component mg sine theta. it got shortened here. So as the theta value decreased, the mg sin theta component decreased. And as theta value was really small, the mg sin theta component was even smaller. And when theta was almost equal to 0, mg sin theta disappeared, which means this component of weight is no longer present here, right? It's only the mg component. Let us see what happens to mg cos theta here. So this would be mg into, what is cos theta? Cos theta is cos 0, which is, cos 0, which is 1. So the only component what we get is mg. And the normal reaction would balance this force. Excuse me. So that is the concept regarding resolution of weight. Okay. Okay. Now I think we can come back to solving this question. Okay. Okay. Now let us come back to solve this question now. Oh, I think the question would span a really long time. Okay. So the upper half of an inclined plane is perfectly smooth while the lower half. Okay. Now, as we said earlier, we will discuss this question in two parts. One will be the upper part, travel from A to B, and the next would be travel from B to C. Okay. So let us write it down first. Travel of the body from what? From A to travel of the body from A to B. Okay. So this is the body here. This is the fixed plane. This is the fixed plane. Inclined body. The angle is theta. The object is kept here. We are talking only about the smooth plane. Okay. So we now know that this vector here is mg sine theta, right? We have another vector here which is mg cos theta. Normal reaction acting perpendicular to the point of the contact surface, and right, these are the forces acting on it. Now what we'll do is we will try to understand the forces acting on it. See, this object is in motion, right? This object is in motion, and when an object is in motion, we know that the net force acting on the body would be actually equal to mass into the net acceleration acting on it. What is the meaning of F net and A net? Pretty simple. F net means the sum of the components along Fx and Fy. A net means the sum of, resultant of the components Ax and Ay. So what is F net? F net is equal to root of Fx square plus Fy square. Similarly, what is A net? A net is equal to root of Ax square plus Ay square. Okay. So this is something we need to understand. Now let us see what are the forces acting on the body here. See, this is the object present here. The vertical component is n here, right? Acting upwards, and the other acting downward is mg cos theta. So if we were to write down Fy, right? If we write down sigma Fy, what do we have sigma Fy as? Sigma Fy would be n minus mg cos theta. Okay. Well, what would be sigma Fx? Sigma Fx would be, see, the only force acting here is mg sine theta acting downwards, right? Mg sine theta acting downwards. So it is mg sine theta. Now, what is Ay? So if you look at Ay, the object is actually sliding downwards, right? The object is sliding downwards and it is not having any motion in the vertical direction. I repeat, say if you consider this block here, if you consider this block, Okay, now I'm not able to select this block. Okay, so this block is sliding down to the inclined plane. It is not going up like this. It's not going up like this. It's not going down like this. It is rather sliding down the surface, which means there is no motion in the vertical direction, which means there is there is no motion in the vertical direction, either in the positive vertical direction or in the vertical direction or negative vertical direction. It is having motion only in the inclined plane, which means along the vertical plane there is no vertical motion, right? So if there is no vertical motion along the if there is no motion in the vertical plane, what can we write for ay? We can write that ay is equal to 0, right? And what would be ax? There would be any component. We say there would be a component present called as ax, right? Now, if ay is equal to 0, what is sigma fy is equal to? It would be m into ay, which is equal to m into 0, 0. But what is sigma ax? Oh, sorry, what would be sigma fx is equal to? We know sigma fx will be equal to m into ax, which is equal to, what is m into ax? The value of ax is mg sine theta, right? M into g into sine theta. Okay, so let us consider only this two part of the equation. So we have m into ax is equal to m into g into sine theta. If you cancel m on both sides, what do you get? What you get is ax is equal to g sine theta, right? So what we get is ax is equal to g excuse me, what we get is ax is equal to g sine theta. Okay, now if ax is equal to g sine theta, let us try to understand the question with even more detail. If ax is equal to g sine theta, what is a net is equal to? It is equal to root of ay square. What is ay square? It is 0. So it is 0 square plus, what is ax square? Okay, let me write it as ax square. So a net is equal to root of ax square, or otherwise a net is equal to ax, and therefore we can say that a net is equal to g into sine theta. Okay, now let us try to understand the motion from a to b. So this is a till b, right? So from a to b, guys, let us not try to pull out the equations of motion in a straight line. So what is equation of motion? So it is v square minus u square is equal to 2 into a into s. Is there any vertical motion here? No, which means we have only the horizontal motion. So it is vx square minus ux square is equal to 2 into ax into s, right? Now, since the object is starting from rest, we can say that ux is equal to 0, right? Since it is starting from rest, ux is equal to 0, which means vx square minus 0 is equal to 2 into, instead of ax, what do we have here? We have derived ax is equal to g sine theta. So into g sine theta into, see, since it's the lower half, since it's the upper half, we know that the upper half here is L by 2, right? So this is L by 2. So what do we get? What we get is Vx square is equal to 2 by 2 is 1, g into sine theta into L, right? So what we get is Vx square is g sine theta into L. Okay. Are we done with the question? No. What we need to find out is, the next is, now we have discussed travel from A to B, right? Now what we'll discuss is travel from B to C. So let us do that part also. So we just derived that Vx, which is actually velocity in the horizontal direction at point B, is actually equal to, what is the value? G sine theta into L, right? So the value is G into sine theta into L. Yes, I do understand. Now you may need the diagram one more time. No issues. We'll draw it. So fixed plane, inclined plane, theta. This is the rough plane, right? The object is now here. Now what is the velocity possessed by this object? it is velocity is Vx, or let us say it is velocity is Vb, and the object is coming downwards, right? And the object is coming downwards. Okay. And it eventually reaches C. And what is the velocity here? Velocity at C is actually equal to 0. See, so velocity at B will actually now become the initial velocity at the point B. I repeat, the velocity at which the body was covering the smooth plane will now become the initial velocity for the rest of the motion. Okay. So we have initial velocity at UB is equal to G into sine theta into L. What is the final velocity? The final velocity is at C, which is equal to 0, because the question says that it comes to rest. So I can otherwise write that U is equal to G sine theta into L. And I can write that V is equal to 0. Okay. Now comes the interesting part, which is the resolution of the forces. Let us see that also. So we have the body here. Now see, since there is, okay, let us not skip that. So normal reaction acting perpendicular to the contact of surface. The weight acting downwards is mg cos theta. We know that the horizontal direction force is mg sine theta. And what will act, see, since the object is moving, since the net acceleration is towards downwards direction, Fk, which is force of kinetic friction, but kinetic friction would be acting in the direction which is opposite to the motion. So opposite to the direction is towards this, which means opposite to the motion, diametrically opposite would be moving in the upward direction. Sliding downwards is the direction of motion. Sliding upwards would be the direction of motion of kinetic friction, Fk, right? Okay. Now, what is Fk? See, we know that Fk is nothing but mu into n, right? Fk is mu into n. Okay. Now what is n? N is mu into n, or sorry, n is mg cos theta, right? So, okay, wait, what is that we're trying to find out here? We're trying to find out the next equation. Okay, so the next equation for the motion from B to C, for the motion along B to C, we have V square minus U square is equal to 2 into A into S, right? 2 into A into S. But this is Vx, Ux, and Ax. Okay. Now let us see, for along the horizontal direction, there's only two forces acting, mg sine theta and Fk. What is Fk? Mu mg cos theta. So if we were to analyze this further, for the motion along x direction, what is sigma fx is equal to? Sigma fx is equal to m into ax, right? Now how many forces are acting along the x direction? One is acting downwards, mg sine theta, and the other is acting sliding upwards, which is mu mg cos theta. See, what is the net direction of motion? The direction of motion is towards the sliding downwards. So whatever is coming downwards, we'll take it as positive, and whatever is sliding upwards, we're taking as negative, which means sigma fx here would be mg sine theta minus mu mg cos theta is equal to m into ax. Okay. So we'll cancel m here. So what we get is g sine theta minus mu into cos theta is equal to ax. Right. This is the derivation we have here now. Okay. Now if we have ax here, can we come back to this equation? Vx square minus ux square is equal to? Yes, let's try doing that. So what is Vx? It is final velocity 0. So we have 0 minus, what is ux? The initial velocity, which is g u square, right? So we have g square. Wait. There's a mistake here, right? It's not Vx, it is Vx square. So it is Vx square, it is UB square, so it is U square. My bad, my bad. So it's not G square, it is U square, right? So Ux square, we derived it to be, Ux square, we derived it to be sine theta into G into L. So we have G into L into sine theta is equal to 2ax. 2 into, what is the value of ax? We have it here, which is g sine theta minus mu cos theta into L. Sorry, into S, right? 2as. What is S? S again is half of the moving length. So S here is L by 2. Okay, S here is L by 2. So let us try to multiply this. So 2 by 2 is 1, right? 2 by 2 is 1. So what we get is minus GL sine theta is equal to G sine theta minus mu cos theta. So if you take G's to the other side, what you get is minus 2GL sine theta. No, there is one L component here. I missed that. Sorry, this whole is into L, right? And this whole is into L. So we have L sine theta, L cos theta would be equal to minus mu cos theta into L, right? And now what will happen? Simple. L by L is 1. So what do we have rest? 2. Okay, minus and minus becomes positive. 2 sine theta is equal to mu cos theta. And therefore, what is mu is equal to? Mu is equal to sine theta upon cos theta, which is equal to tan theta. Okay, 2 is here, right? So mu will be equal to 2 sine theta, so 2 tan theta. And therefore, what we get is the correct option is mu is equal to 2 tan theta. Okay, see, it's a really long derivation. Well, actually, we do understand that it's not possible to watch such a really lengthy explanation. But the reason why I took it, as I say that in every video, it's to make sure that you understand the concept behind every question. So just imagine the kind of concepts that are asked in one question. It covers friction, it covers resolution of weight, it covers your concepts of resolving forces on an inclined plane, it covers your concept of application of equations in a straight line, it covers interlinking all these, right? So it's a really good question. And see, when you do this for your exam, right, when you do this for exam, things are really simple, because you know that for the force acting is g sine theta. When there is friction law, it is g sine theta minus mu cos theta. So you have ready-made answers with you. But as I said, these lectures are designed for those students as well who cannot or rather who need more and more detailing in the concepts. Okay, so I would like to apologize one more time for this lengthy video. Sorry, students. So okay, having said that, let's move on to the next question.